Look at these two math tests. Both students received exactly a 75%. On paper, they appear to be in the exact same academic position. But review the actual work. The first student applied the correct formula perfectly, but dropped a negative sign in the final step. The second student performed the arithmetic flawlessly, but selected entirely the wrong mathematical formula for the problem. The percentage tells us how many points they earned. It completely obscures what they did wrong and why they did it. This introduces a critical research concept, construct validity. This asks a simple question. Does your measurement actually reflect the specific knowledge you claim to be testing? A flat percentage lacks construct validity for planning instruction. You cannot build tomorrow's lesson on a 75. To know what a student actually needs, you must track observable patterns of evidence. To find those patterns, we use a process called operationalization. This is how we take a broad, abstract learning target and break it down into specific behaviors we can actually see. Take a common mastery target. Justify theme using textual evidence. To operationalize this, we split it into a matrix of 4 distinct components: theme accuracy, evidence selection, explanation clarity, and connection logic. We have to avoid weak indicators that merely confirm a task was finished. Noting that a student wrote a paragraph tells you nothing about their comprehension. Instead, we require strong indicators, like language references observable evidence, which will expose exactly where their logic breaks down. We evaluate these strong indicators on a simple 3-point scale: demonstrated, developing, and not yet demonstrated. Applying this to a student's paragraph, we trace their argument to this specific sentence. The reasoning is tangled and contradicts their earlier point, earning a not yet for explanation clarity. By operationalizing the standard into a matrix, the true nature of the misunderstanding becomes visible. You now have actionable data. Now it is your turn. We are going to look at a second student's work and grade a single row, connection logic. Pause the video here. Read the response on screen and decide which of the 3 scale symbols applies to their connection logic. The correct code is developing. The student provides a quote, but as highlighted here, only vaguely links it back to the theme without explaining the metacoder reliability. When professionals disagree on a placement, it means the language of your indicator is flawed and must be revised. An indicator matrix only works if 2 different teachers can look at the exact same assignment and produce the exact same visual evidence pattern. Once you collect these symbols, do not average the check marks and X's back into a single percentage grade. That is the percentage reflex, and it defeats the entire purpose of the matrix. Look at the visual shape of the data instead. A matrix dominated by not yet marks creates a below-trend pattern. This student requires immediate Tier 1 reteaching or Tier 2 intervention. A mix of marks forms an on-trend pattern, indicating they need targeted, differentiated practice. A block of mostly check marks creates an advanced pattern, signaling readiness for extension. Your instructional placement is dictated by the shape and pattern of the data. A mathematical average buries the root cause. The pattern reveals it. When you sit down to plan, this matrix does the heavy lifting. If a cluster of students shows a gap on the connection logic row, you bypass generalized review and pull the exact mini-lesson designed to fix that specific missing link. To make this work in your own collaborative teams, follow this 4-step checklist. Step 1. Operationalize your target into 3 to 5 observable skills. Step 2. Filter out weak indicators that only track task completion. Step 3. Calibrate your team against real student work to ensure intercoder reliability. Step 4. Group your students based strictly on the pattern logic. Transitioning away from percentage grades eliminates the guesswork of instructional planning. By capturing and tracking exact behaviors, you isolate the exact barriers blocking your students, allowing you to build a direct path to true proficiency.